That was Aaliyah every morning. Ah, it's not 8:30 yet. We can't start. Can't start. It's not 8:30. Hot in here too. All right. What about your homework? Everything. Yeah. I think I did 5. I did 5. I did 6. 6. 5 or 6? 6. All right, here we go. Find the derivative. Product rule here, gross. All right, derivative of the first is 1 times the second plus the first times derivative of the second. So 1/2, 1 minus s squared to the negative 1/2. I think, Preston, is this the one we did yesterday? And then chain it. And that's it. Now on to the next one. Inverse cosine is -1 over the square root of 1 plus s squared. And I don't have a chain there, so that's good. Let's clean it up. I see a lot of 1 minus s squareds. I am going to cancel out the 2.5. So now I have, this is actually going to be a minus, isn't it? Minus s squared, and I'm going to put this on the bottom with a square root. I need to be consistent with what I'm doing here. Plus -1 over square root of 1. Is it plus 1 plus s squared there? Did I write it wrong? Hey, I was about to say, I know this. There you go. I was going to say that can't be right because that's going to be nasty, and the answer is not nasty. Okay, common denominators. I'm going to give this one a 1 minus s squared, which means I need it up top too. And since I'm multiplying it by itself, the radical is just going to go away. So I have 1 minus s squared minus s squared minus 1 all over the same bottom. Negative 2s squared over the square root of 1 minus s squared. Is that what they got? I'm always scared to look. Yeah. I'm sorry I forgot y'all's metaphors this morning. I thought about it when I got here. Y'all didn't remember either, did you? I shouldn't say anything. Yeah. 7. Text me. I'm telling you, I have a mountain of them. And I have even more now because I have a ton of orders for this weekend and I boxed them all up last night. Yeah, there you go. I don't know. Right now I'm watching that show. I've only watched the first episode. It's on Netflix. What's it called? The Watcher. Have y'all seen that? I could not sleep last night. It's like the psychological kind of scary, you know what I'm saying? I mean, oh my gosh, it's a little freaky. I've just seen the first episode. It's really good. It's a little. Now I heard it didn't end well, but I don't know. I'm in. Okay. Derivative. I'm sorry, y'all. I'm ADD today. Derivative of the first, 1 times the second, inverse sine, plus the first. Now I need the derivative of inverse sine. That's the one, nope, that's the positive one. 1 over squared. Plus, now I need the derivative here, so I'm going to do power and chain. Good to go? All right, let's see. I'm going to cancel the half and the 2. But Hope and Giselle are going to go back and watch this and hear me talking about my show. Sorry, y'all. I forgot to pause it. I'll pause it next time I get sidetracked. Okay. Yes, I'm going to keep it. I'm going to change this sign probably to minus to account for that. All right, plus, I'm going to put this x up top. Minus, and I'm going to put that x up top, and I have the square root of 1 minus x squared. Well, that's convenient. They both have the same denominators. Oh, and they're both the same. They're wrong. Is that what y'all got? Well, that was nice. Okay. 21. Oh, great googly moogly. Okay. Inverse tan. I have to take my time through these, so y'all. Inverse cosine of x. We didn't do this one yesterday? Okay. This one supposedly equals 0 also. I've got some domain restrictions there, but that's going to have to be, we don't have to worry about that right now. All right, here we go. Tangent 1 over 1 plus x squared. Chain it. Yes. Plus inverse cosecant negative 1 over absolute value of square root of x squared minus 1. Okay. No, because this is addition. I did them completely separate. Like if I just found the derivative of that, that's what I have here, and then just find the derivative of that. They don't impact each other since you're adding. Okay, so I have 2x over 1 plus x squared minus 1. Minus 1 over the absolute value of x times the square root of x squared minus 1. Too fast? Sorry, I'll wait. I'm gonna write this fraction first, then I'll stop and wait. How in the heck did they get 0 there? I don't know. Oh, from chain. Oh my gosh, you're right. I didn't chain it all the way. I need to also multiply it by 1/2 x squared minus 1 to the negative 1/2. You are absolutely correct. Thank you, Jalen. So here, instead of just by 2x, I jumped straight to the inside. I didn't get I forgot y'all's lollipops too. I didn't do the outside. I didn't chain, because this, what's the derivative of that? Well, the derivative of square root of x squared minus 1 is 1/2 x squared minus 1 negative 1/2 times 2x. So whenever I chain it, I need all of that instead of just 2x. That was a good catch. Sorry. Okay, which means you're right. The 2 and the 1/2 are going to cancel, so this 2 is not here anymore. And that means down here on the bottom, I still have a square root of x squared minus 1. Well, there's why it's 0. Thank you. Okay, so the problem happened. You see why whenever I didn't chain, you understand why. Okay, so what happened here? The 2 and the 1/2 canceled, right? So now I don't have this 2 following down this first fraction anymore. It's a 1. And on the bottom, I have the square root of x squared minus 1. It's not really impacting my answer other than in the end, my denominators are actually the same. Right. Because if you, well, this is why, which number, where am I at here? 21. It gives you the stipulation that x is greater than 1. So if x is always greater than 1, it's always positive anyway. So as long as it's always positive, it's going to be the same denominator. 1 minus 1. Okay. I cannot believe I didn't change just now. Rookie mistake. Yes. I need to redeem myself and do another hard one. Okay, 13. Inverse secant. I did that on purpose to see him both. Y'all ever have teachers used to tell you that? I did that on purpose. Not true. It's a lie. Especially me. Did I say that all the time? All right, 1 over. Secant is absolute value. Square root of 2s plus 1 squared minus 1. Now I chain it. Yes. Do I have any restrictions on this one? Nope. Square root of, let's see, 4s squared plus 4s plus 1 minus 1 are going to cancel out, right? I'm going to take a 2 like that. Square root of 4 is 2, right? I don't know that there's anything else you can do. You talking about here? Because what I really did was I said, okay, 4 times s squared plus s. That's the square root of 4 times the square root of s squared plus s. Square root of 4 is 2. And then I canceled the 2 with the 2 at the top. Is that where they stopped? Okay, good. Cool. Yes. I'm going to do it this time. I'm going to remember to change. Inverse cotangent, square root of t minus 1. The derivative here would be plus x squared times. Now chain it. 1/2 t minus 1 negative 1/2. And then the derivative of that is just 1, so it doesn't matter. Y'all stop me if you see me doing something wrong before I get through the whole thing. 1 over 2 root t minus 1. So this is negative 1 over t. Oh, this is times. So 2t. Is it? Yes. Square root of s squared minus 1 minus the inverse of a secant. I'm just bored. Sorry. I'm almost done. Derivative here, 1/2 times s squared minus 1 to the negative 1/2 times 2s. And then inverse secant. Have y'all memorized these yet? No? I have my green sheet in front of me right now. I did memorize them right before the exam. It wasn't, I didn't really learn them. I memorized them right. I told y'all that though. I put them on flashcards. The last time I remember I was driving down the road to Coastal because that's where I did my certification class with note cards flashing as I was driving down the interstate. I remember my derivatives and integrals. Looks like I need an absolute value of s for the first one. So I get the absolute value of s minus 1, bless you, over... Oh. Oh, you're talking about up top. You're right. There you go. Did they put those together? Or did they leave it like that? So they made it s squared? S times absolute value, okay. But really, why couldn't you? Oh, that's right, because this is the same situation. Is this the one we talked about? You and I talked about? That's right, because if s is negative. Well, we were just saying, like what was the one we were talking about? T cubed times the... So we were talking about, could you cancel that? Could you make that t squared? And the answer would be no, because this is always going to be positive, right? Absolute value, this is always going to be positive. But if you had a negative that you plugged in there, and it was negative, that's going to force this whole side to be negative. But this side could never be negative because you're squaring it. So it wouldn't make sense to cancel one out there. So that's why. Same kind of situation here. This is always going to be positive. Now, if you had a stipulation in the beginning, like if it said that s is always greater than 0, then yeah, you could combine those to s squared and that wouldn't be a problem. But because you don't, you need to leave it like that. What else? Oh, is it? Okay. 1 over t. And it says that, oh, maybe, Abby, we could, because I didn't know that there was a restriction on there. Yeah. So, yeah, we could. It's definitely going to stay positive. All right, here we go. Did they on their solutions? I'm sure they did since this. Derivative here. So secant is 1 over absolute value of x square root of x squared minus 1. Now I need to chain it. So this is really t to the negative 1, right? Negative 1t to the negative 2. Okay. I'm going to make this negative 1 up top. This is going to be t squared, absolute value of 1 over t, square root of 1 over t squared minus 1. So yes, we can cancel one of these out for that reason. I was just looking under that radical. T1 minus t squared over t squared. I guess you could combine those if you want to. So we got, I'm going to cancel one of those out because I can here. The absolute value is really not even necessary. If your t is in here, if you look at the problem, because of this restriction, it's always forcing t to be positive anyway. So I wouldn't be plugging in anything that was negative. So it's really not even, the absolute value is not even necessary, really, is what I was getting at. But we'll put it there. This does not look at all like what they have. Let me finish working it. I'm going to put this in one fraction. 1 over t squared minus 1. So I'm going to make this 1 over t squared minus t squared over t squared. So 1 minus t squared over t squared. Uh-huh. Y'all okay there? Why did I do that? So I did that because now, when I combined them, I wanted to combine them because there's a fraction and a fraction. I want to try not to leave a fraction within the fraction if I can help it. But what happens here is I have negative 1 over, I've got the absolute value of t, which that's irrelevant, but still. Because I've got this in a fraction this way, I can take the radical to the top and the bottom, right? And the square root of t squared is just t. So now, let's cancel out. So this is negative 1 over the square root of 1 minus t squared. Does that make sense? And again, that restriction allowed me to do that because I have to be careful with that absolute value. So I did the radical to the top and the bottom of this fraction. I did it here and here, and the square root of t squared is t. All right, y'all ready to talk about today? Yay, we can't wait, Miss McGee. I'm so glad. You may not like her. If you don't like her, it's okay. Just like your hair. Y'all remember that where we verified it. I'll write that down. This is usually a multiple choice question where they'll ask you something of this sort. Yeah, what she's got boxed in there. This is only if F and G are inverses of each other. Because what does inverse mean? Switch X and Y, right? Y'all have any idea what to do? Derivative of the equation at that point, and then all you have to do is she's right though. Maybe one, two max, but they will show up. Guaranteed it's going to be there, but probably once. Okay, so let's see if you can do it now. It's not a real hard concept. It just can get a bit confusing. I'm going to do these in the style that your book has them in, and we'll do a lot more practice with these, more in the style that of the AP style. Here's my function. The first thing I want to know is what is f of 1 and what is the derivative at 1? Straightforward, easy questions. I'm going to find the derivative here. That's a terrible first example. All right, so that's just at 1 and the derivative at 1, right? But now we're talking about inverses now. I should have labeled this as inverse derivatives, but anyway. What if I asked you now, what is the inverse? What is the inverse of 10 here? Because all that's doing is switching x and y, right? And this is why I said this is a terrible example, because they're both the same. But what if I asked you, what's the inverse of the derivative at 10? What do you do? What did we do? Go back to your little, say it again. One over the normal derivative. That's exactly right. So it's actually 1/10. We're flipping this one. Let me do a better one. Let's say f of x is x to the 5th plus 3x cubed plus 7x plus 2. Do one here that has different values. Let's do at 1. So let's do f of 1 and the derivative at 1. 1 plus 3 plus 7 plus 2, which is, yes, 11. 4, 13. Yes, it's x to the fifth, 3x cubed, 7x. And now the derivative then, 5x to the fourth, 9x squared plus 7. So the derivative at 1 would be 5 plus 9 plus 7, which is 21. So now what is the derivative? What is the inverse's derivative at 13? Okay, so because I'm inverse, I'm switching x and y, right? So I'm talking about, this is no longer, okay, what is this? 1, right? Because this point is really just 113, so the inverse of that would be 13.1, right? So now I'm looking at this inverse. So the inverse at 13 would be when the inverse here, when I'm plugging in 1 and I'm going to reciprocate it. So it's going to be 1 over 21. Does that make sense? These are quite confusing. I feel like the AP style ones are a little easier than what these are, looking at them this way. Or maybe it's easier for you to do, here's f of x, the way she did, here's your inverse. Kind of thing, and find the slope there. No? Huh? So you flip it. It's always the reciprocal because it's that little formula you wrote down. It's always the reciprocal. Here's what you, let me give you some little steps. Maybe this will help. We did the derivative, right? Swap x and y. And then we substitute in. And then reciprocate it. I feel like this is falling flat. I'm doing a terrible job. Try this one. Find out that will be given to you. So like literally it says find find S of 0, find S prime of 0, find the inverse of the derivative at 1. Cosine of 0 is 1. Does that make more sense now? That's kind of the way she set it up when she did it. So the point on the original function is 0, 1. So that point on my derivative is 1, 0. Right? I'm not on the derivative, on the inverse. Sorry. Right? Because it swaps. So then the slope, which is the derivative, slope here is 8. So to find the corresponding slope of the inverse, I just reciprocate it. Does that make sense? So that's why it's 1 on the inverse, but looking at the original function, that's when y is 1, not when x is 1. You have to switch that x and that y. Does that make more sense? A little bit? So when I'm looking at this, this is where I'm looking for the y value of the original. I'm looking for that y value on the original, which is here, right? And I want the reciprocated slope there at that point. Does that make sense? Or some of you are saying yes, and some of you are like, this is no bueno. Let's do one more. Yes. So you have to find, right, so you're finding where the original function equals this. Well, it's there because just to show you how it kind of correlates with the other kind of thing. All right, let's do this one. See if this is better. See if you can do this one on your own. X to the 5th plus 2x cubed. This one's actually in your book, I think. Plus x minus 1. I want to know, let's find f of 1. Then let's find the inverse at 3. Then let's find, maybe if I word it like this, it'll be, then let's find the derivative. And hopefully this is going to give me the answer to that, right? This is inverse. I'd switch it to see if it helped you a little bit. Here's what you're looking for. Yes. You're going to have to find the derivative, because to find this, I'm going to have to find the derivative at this point. Right? All right, well, let's look. Here's this. Here's inverse, right? This point is 1, 3, which means this point corresponds with 3, 1. Agree? I need the inverse derivative at 3, right? So that means look where y is 3 in the original here. Find the derivative and reciprocate it for here. Well, we're going to have to go back to this original equation to find the inverse. So what we need to find is f prime of what? Of 1. Because this is going to be 1 over this. Okay, so find your first point, right? You understand how the inverses work. You're switching x and y, yes? That makes sense? Okay. At that corresponding point, the slopes are reciprocals. Okay, so if I find the slope of this one, then the slope of this one is just the flip of that. So what I'm doing is, if all I had given you with this was I said, what is this? The first thing that I would need to know is, well, where is the function equal to 3 initially? Oh, I kind of gave you a hint by giving you this to show you that if you plugged in 1, you get 3. Right. And that's probably what they'll do. They'll probably say, you probably won't have an equation as often as you'll have f of 1 equals 3. F prime of 1 equals whatever this equals. What is it? Has anybody done it? 12. What is the inverse, the derivative of the inverse at 3? Well, that's 1 over 12. You only have like 2 of these to look at. See if you can get them though. Actually, she's 1. And we'll do some more practice with them. I'm going to stop. I can tell y'all are getting frustrated. I'll see if I can find you something else to explain better. We're going to do 35 through 37 and 45 through 48. Those are multiple choice. These sections get hard at the end. These chapters get hard. I think we only go through 3, 4 on this, yeah. We've only got one more section and we'll be done with this chapter. We'll be ready for a test. So section 4 is a doozy. So we'll camp out there for a little while.